channel. Today we'll be discussing about linear momentum. So, for deep understandings of linear momentum, we should be familiar with this topic. So, as you can see on the board, for deep understanding of linear momentum, we must understand what is momentum, what is impulse, and the Newton law of motion. So, the first one, momentum. When we talk about momentum, momentum is the product of mass and velocity. It's always the product of mass and velocity. The abbreviation for momentum is given as this. Momentum equals to product of mass of a body times its velocity. So, and the SI unit of momentum is given as kilogram meter per second or Newton seconds. So this is the SI unit of momentum. So let's look at impulse. Impulse can be defined as the product of the force acting on the body times the time during which it acts. Is simply known as the product of force and velocity. Impulse is also known as a change in momentum. You can also call it a change in momentum or the product of force and time. So when we have impulse here, impulse is given as this: force times time, or change in momentum. So these are the two formulas for impulse: product of force and time, and change in momentum. So remaining this. So the Newton law of motion. Newton law of motion. So Newton is a great scientist that have done more work on classical physics. He was the one that came up with this laws of motion. So he came up with 3 laws guiding motion, which I'm going to state now. So the first law of motion states that an object will continue in its state of rest or of uniform motion in a straight line unless acted upon by an external force. An object will always continue in a state of rest. It will continue moving. It will remain in the same place unless it is acted upon by an external force. So the first law, we have explained this. Then the second law. So the second law states that the rate of change of momentum is proportional to the applied force and take place in the direction of that force. The rate of change of momentum is proportional to the applied force and take place in the direction of the force, which can be represented as this. Change in momentum. Is this. Remember that momentum is mass times velocity minus m. This represents the final velocity, while this represents the initial velocity. So change in momentum is given like this. The rate of change in momentum is given as this. Now, because rate of change, we are going to introduce time here. So, when this second law states that the rate of change of momentum is proportional to the applied force, so we write our force proportional to the applied force. So, as you can see from the bar. So, if you look at this now, this is a representation of the second law of motion. So the third law of motion is very simple. It states that action and reaction are equal and opposite. Action and reaction are equal and opposite. So that is very simple. So we have explained the third law. So if you look at this, let's derive formula. So we have already given the formula for momentum as this, and the formula for impulse is this. So whenever you are given a question to solve, depending on the question given, you know the types of formula you are going to apply. So let's dive into a problem concerning linear momentum. So looking at the question we have from the bird, a net force of magnitude 0.6 Newton acts on a body of mass 0.4 kg initially at rest. Calculate the magnitude of the resulting acceleration. We are asked to calculate the acceleration. So write down solution. Remember, the formula for force is given as mass times acceleration. Remember that this mass times acceleration is derived from this formula. F equals to change in momentum over time. As you can see, we have m and m here. We pick one, we bracket it, v minus u over t. And if you look at this now, we have final velocity minus initial velocity over time. And remember, acceleration is known as change in velocity, but here change in velocity with time, but here you have change in velocity with time, meaning that here everything here is the same thing as what? Acceleration. So that is the way we derive this. So this and this, they are the same thing. So we'll be making use of this F equals to mass times acceleration. So we are given force to be equals to 0.6 Newton, and we are given mass to be 0.4 kilogram. So we are asked to calculate the acceleration, which is unknown. So we are going to substitute everything here into this formula. So we have F equals to mass times acceleration. F equals to 0.6 Newton. Since Newton equals to mass is 0.4 kilogram. 0.4, then you have your acceleration. So 0.6 equals to 0.4 times acceleration, we have 0.4 a. So as you can see it now, 0.6, 0.4 times this, we have 0.4 a. So we are going to divide both sides by 0.4 to get at this. So let's rearrange. We have 0.4 a, 0.6. I just rearrange them Then we divide both sides by 0.4. 0.4. So here we have 0.4a divided by 0.4 equals to 0.6 divided by 0.4. So here 0.4, we cancel 0.4, and here we have 0.6 divided by 0.4. We are going to have 1.5. So when this here 1, this here 1.5. So we have our acceleration equals to 1.5, and the unit for acceleration is meter per second square. So this is our final answer. So it is very simple. Just take a look at this. Force equals to mass times acceleration. Our force is 0.6, mass 0.4 times a. We get this. So to obtain our a now, we divide both sides by 0.4, and when we do that, our answer is 1.5 meter per second. Okay. So let's dive into the second question. Right. Thanks for following up. Yeah. We are into the second question now. A trunk of mass 3,200 kg moving with a velocity of 10 meters per second increases its velocity to 20 meters per second in 5 seconds. Calculate the magnitude of the force exerted on the engine. Here we are asked to calculate the magnitude of the force, the value of the force exerted on the engine. So solution. So here we are going to be using our Newton's second law of motion, the formula concerning Newton's second law of motion. So So the reason why we are making use of this, because we have two formulas for force. We can either use this one or we use this one. But the reason we are making use of this one here is that we are given different value here. We are given the mass, we are given the velocity, we are given the time. But when you take a look at this, can you see acceleration here? No, you are not given acceleration. So we are not going to make use of this because there is no acceleration in the question. So we'll be making use of this one. So here we are given our mass to be equals to 3,200 kilogram, and we are given our initial velocity to be 10 meters per second, and we are given our final velocity to be equals to 20 meters per second. So, and we are given time to be equals to 5 seconds. So we are asked to calculate force. So we'll be looking for this. So the next thing we are going to do now is to substitute all these values into this formula. So we have our F to be equals to, the mass given here is 3,200. So as you can see from here, let's simplify this to look like this. When we open this bracket, we have something like this. So our mass is 3,200. Our final velocity is 20 minus our initial velocity is 10 all over. Our time is 5 seconds. equals to. So theory 2 bracket times 20 minus 10 will give us 10. So we have 10 here all over 5. So equals to theory 2 times 10. We are going to have 32,000 divided by 5. So if you look at this, we are almost there to our final answer. As you can see from here now, we use this formula mv minus mv all over t. But if you are going to introduce 32 here times this minus 32 times this, it will make the solving to be cumbersome. So I thereby simplify this formula by doing this, as you can see. So here we have our mass to be 3,200 bracket this 20 minus 10 and divided by 5. 32 times 10, we have 32,000 divided by 5. So 32,000 divided by 5, as you can see, we have 62 because first can also be measured in joule. So force is measured in Newton. So we have 6,200 Newton. So this is our final answer. As you can see, it is very, very simple. So there are a lot of questions concerning linear momentum, but I just picked this one up because of reference purposes. So if you have any question pertaining to this, or if you have any other question, please remember to drop down your question in the comment section. So remember to subscribe to my channel. Thanks for watching.